when you factor, we have a common factor among both groups, namely what's in parentheses. That's good. We want that. That's what we want. Because now, as you can see, we have this. But now, hopefully, you can see that we can factor out x minus 2. And that's what we do. That's why that's what happens. We have something in common, namely x minus 2, as you can see. And then we factor it out. And by pulling it out, as you can see here, what we do to get what's left over is we divide. As you can see, what's next? We divide, and we divide into each term, okay? And then, of course, as you can see here, hopefully from let me write it out with a pen, right? What do you do next? You cancel these things, okay? Those are canceled, and what's left over is this. So that's what's left over. All right, that's good. So now, because that's left over, right, that's our answer. Well, actually, I shouldn't say that. This factorization becomes this. If you go back to the original, we had 2 times this thing, right? And we just factored what's in parentheses, so we get 2 times this. And that's our final answer. Okay. All right. Okay, so let me keep going. I'll do another one. So here's another example, okay? And again, just like with the previous one, right? What we want to do is we want to use factor by grouping. The first thing we want to do is see if we can find any common, see if we can find the GCF of this thing. Let me just check something. Just want to make sure it's not frozen. Okay, it's not frozen, good. So first we want to see if we can find the GCF of this. Okay. Well, hopefully right away you can see that if you look at the factors of 7 and 5, so I listed those factors here, okay? I listed them. But you can see that 7 and 5 alone only have 1 as a common factor. Well, that tells you right away that the only factor in common to all the numbers has to be 1. So since 1 is a common factor of 7 and 5, is the only common factor of 7 and 5, it can only be the common factor of all the numbers. The coefficients and the constant term. I mean, you could list the, the factors of 28 and 20 if you want to. I'm just showing you here that you really don't have to. So the greatest common factor among the coefficients and the constant is 1. And you could also see that the smallest power of x is 0. Smallest exponent of x is 0, excuse me. So you can't factor out x at all. What does this all tell us put together? It tells us that the GCF of this whole thing, right? That's what that bx to the m is, has to be 1. In other words, the GCF of this polynomial is 1. Okay. All right. Now, with that said, let's dive into the factor by grouping. So again, you have to form 2 groups of 2. And notice what I did here. Remember, when you have subtraction, you do have to be careful with parentheses. To make it easier, what I did was I changed this subtraction to adding the negative. That's what I did. Mostly because it makes it easier when you put the parentheses in. Now, Notice also what's going to happen is if you looked at the second and the fourth term here, these two are opposite each other. Excuse me, the signs are opposite. You know, this is a minus, this is a plus. So not now, but later on, we will have to factor a negative out of this. Okay, so let's handle the two groups individually. Okay, so for the first group, right? Well, notice that the smallest exponent of x is 2, right? That's what the m is. And here we do list the factors of 28 and 20. And you can see that the biggest common factor among them is 4. Okay. So because of that, from this alone, we have the greatest common factor of 28 and 20 is 4. So we can only factor out 4x squared. That's the GCF of this thing. Okay. Okay, that's good. So we're going to factor that out. Okay. And that's what I'm doing here, right? You divide to see what's left over, like so. Okay, so this is what we have. Now we want to handle this thing. And notice also that even though this has a GCF of 1, I mean, hopefully you can see why. I mean, mostly there's a non-zero constant term. So there's no x we could factor out. 5 and 7 we saw only have a common factor of 1. So the GCF of this thing has to be 1. But again, since the second and fourth term have opposite signs, we have to factor out a negative number. So we factor out -1. So the only thing we could factor out from this is 1. That's the only common factor. But since we have to factor out, since we have to factor out a negative, we factor out -1. Okay, does someone have a question?
How would it be +5 instead of -5?
Because in the previous slide, let me go back to the previous slide. We have this, but then what I did was I factored out -1. Wait, because that's what we have over here.
Mm-hmm.
And we're going to factor out a -1. Does that help or?
Well, the reason I said it was because like it was like 28x cubed minus 20x squared, and then the GCF of the whole thing would be 4x squared, and then that would lead to it being 7x. And then if it was like positive 4x squared and it was negative 20x squared, like when.
Hold on, let me finish the example, then you'll see what I mean, okay?
Okay.
Thank you. Okay. But anyway, when you factor out the negative, okay, we have -1. And again, you divide to see what's left over. So we get 7x minus 5 here. And so that's what's going to happen over here. But now, by doing that, we now have a common factor. I mean, really, we're just taking out this -1, so we have something in common among the parentheses here. Right? We have 7x minus 5. And that is what we're going to take out, as you can see. Because once you take that out, what we do is we're going to divide into each term to see what's left over. Right? And when you divide, let me get the pen. Right? These are going to cancel. Okay. right? So again, we went from here, we got this, and now we're factoring out that 7x minus 5. We put it in front, we're dividing to see what's left over, and by doing so, we get this. And you could actually go a step further here, as I'm going to show you. I know this example is kind of long, I know. But basically, that's what I'm doing here. I mean, normally on an exam, this would be where you can stop, because that's all I'm looking for. But if you were to actually use this formula here, you would actually be able to go a step further. That's what I'm doing. I know this example probably is, you know, it's long, I know, but that's okay. And altogether, we get this. I know this topic's kind of tricky, I know. I mean, this one I wouldn't put on an exam because you have this extra step at the end. So let me just, okay, so we have that. All right. Oh, geez, no. Okay, so let me just pause, stop the recording.